Good day and welcome once again to chemistry tutorials with Tutor Taye Emmanuel Oyedun. We are going to be solving this question in today's class. In the reaction below, 100 cm cube of carbon 2 oxide was burnt in 70 cm cube of oxygen. Calculate the total volume of the gas mixture in the reaction, assuming the temperature and pressure are adjusted to their initial values. That means the temperature and pressure is constant. Then you have the chemical equation. This is a question on Gay-Lussac's law of combining volume. Okay, so the first thing to do is to get the stoichiometry of the reaction involved here. So you have 2 moles of carbon 2 oxide reacting with 1 mole of oxygen gas to produce 2 moles of carbon 4 oxide. Now let's now go to the question again. It says in the reaction below, 100 cm cube of carbon 2 oxide was burnt in 70 cm cube of oxygen. It means before the reaction, carbon 2 oxide is 100 centimeter cube, while oxygen gas is 70 centimeter cube. Okay? Now, to now proceed now. During the reaction now, by the time this reaction takes place, because their stoichiometry is 2:1, it means 100 cm cube will require 50 cm cube. Right? If you have 2:1 and you have 100 ratio x, what will be x? You cross multiply. 2x is equal to 100 times 1, and that's what divide both sides by 2. That will give you 50. So that's how we arrive at 50. Okay? It means you have 100 cm cube of CO, that's carbon 2 oxide, would require 50 cm cube of oxygen gas. Okay? So at the end of the reaction, 100 cm cube was supplied before the reaction, 70 was supplied here. So how many will be left? 100 was used. We have 0 cm cube. Okay? Out of 70, 50 was used. 70 minus 50, you have 20 cm cube left. I hope you are following. Then what volume of the product will now be formed? Just pick any of the reactants, their stoichiometry, and relate it with that of the product being formed. So for instance, if I'm picking oxygen, the ratio of oxygen to carbon 4 oxide being formed is 1:2. And what volume of oxygen participates in the reaction? 50. So from the concept of 1:2, if 50 cm cube participated, it means it will produce what? 100 cm cube. And if you like, you can use that of carbon 2 oxide as well. 2:2. 100 cm cube participated during the reaction. Definitely to form 100 cm cube still. Any of the reactants relating to the product will give you the exact volume. Now the question asks is calculate the total volume of the gas mixture in the reaction. That is also known as the residual volume. What they are asking you for is the residual volume in that reaction. And residual volume simply means the volume that remains in excess and the volume of the product formed. That will now be 20 cm cube plus 100 cm cube. And that will give you 120 cm cube. I believe this question helps somebody to understand chemistry much better. Kindly subscribe to our YouTube channel and follow our page for more videos like this. Thank you. See you in the next class.